we will start the process scheduling. So before starting the process scheduling, I just want to recap something. So these are the outline of our course: process scheduling, queues, schedulers, dispatchers, scheduling criteria, and the preemptive versus non-preemptive scheduling. So what is process scheduling? The process scheduling is the activity of process manager that handles the removal of running process from queue and selection of another process on the basis of particular strategy. Process scheduling is an essential part of multi-programming operating system, such as operating systems allow more than one process to be loaded into the loaded process share the CPU using time multiples. The operating system maintains all PCBs in process scheduling queues. The operating system maintains a separate queues for each process states and PCBs for all processes in the same execution state are placed in circle. When the state of the process is changed, its PCB is unlinked from its current queue and moved to the new state. So this is the diagram from our previous class. These are the process states. So there are how many states? There are 5 states: new, ready, running, waiting, and done. So whenever a process is submitted into the system, it will go to the first new state. From the new state, it will come to the ready state. So ready state is nothing but a queue where process has to wait to get their next state. So from the ready to it will go to running state. From the running to it will go to the exit of running state. From the running it will also go to the waiting state. From the running state it will also go to the ready state. So whenever there will be some IO event will be occurred, a process will come from running to waiting state. Whenever IO event is completed, then process will move from waiting to ready state. So there is a method that is called the scheduler dispatch. From ready to running state, there is a phenomenon is occurred that is called the scheduler dispatch. So whenever there will be some interrupt in the system, so process will move from running to ready system. So this is the diagram. Is the just recap the previous class. That is the PCB. What is PCB? Process controllers. What are the content of the PCB? Process state, program counters, view registers, CPU schedule, algorithm, accounting and business information, memory management information, IO state information. And this PCB is mainly holding the information regarding each process. Assume there are P1, P2, P3 up to n number of processes. That means in your system there are n number of PCB created. That means P1, P2, P3, P4. So by this manner, whenever a process will switch from one process, whenever our operating system usually switch the control from one process state to another process state. So all the state related to process 1 will be stored in a PCB 1. Similarly, whenever process 2 whenever there will be the phenomenon, the control will go from process 2 to process 3, then PCB 2 will hold the information of process 2. So similarly, whenever switching between process 1 to process 2, this phenomenon is called the context switching. So what are the process queue are there? So usually there are 3 types of queue in our operating system. The first one is the job queue. The second one is the ready queue, and the third one is the device queue. What is job queue? Just see the diagram. Whenever a process is submitted into the system, our process is mainly is submitted to job queue. So from this job queue, our process will go to the ready queue. From the ready queue, our process will go to the CPU. From the CPU, it will go to the IO queue or the IO waiting queue or the waiting queue. And next, it will go to the ready. So what is job queue? This queue keeps all the processes in the system. What is ready queue? This queue keeps a set of all processes residing in main memory, ready and waiting to execute. A new process is always put into this queue. What is device queue? The processes which are blocked due to unavailability of input-output devices constitute this queue. So how many queue you have to remember? You have to remember 3 types of queue: job queue, ready queue, and the next. So now consider one real life experience. So assume in this weekend you want to go to a restaurant or a restaurant. So where you want to have some food. So before reaching to the restaurant, you have planned what are the food you want to eat or what are the things you want to eat. So whenever you reach to the restaurant, that means there will be a person will be waiting into the door or just in front of the restaurant. So if the dining hall is empty, then he will allow you to go to the directly to the dining hall. If dining hall is already occupied, he will tell you you have to wait or you have to stay in a queue. So assume this waiting room is here where some sofa is there. This is the waiting room. This is the dining hall. This is the kitchen. So whenever you enter into this room, so you will have to stay here. So this is the ready. So now whenever some table or the space is available into the dining hall, next there will be another person. There is another lady or another person is here who is also come to the waiting lounge, or she will pick up the customer from the ready queue, who will be the next. So she will take them to the dining hall. So in this dining hall there are 2 more persons, this person and this person. So whenever she will go to the dining hall along with the customer, she will hand over the customer to a person. So this person maintain the sequential execution between kitchen and the dining hall, and his work is quite fast. So okay, now just there is another person. This person is also responsible for making the arrangement of sitting or the waiting or the bill processing. This thing will be. So similarly, in our operating system, whenever a process is come to our system, a process has to submit in a job. That is the first thing is the job. So this is called the pool of job images. So from this job queue, there is a computer program or software program that is called a long-term scheduler. This long-term scheduler will pick up processes from the job queue and it will submit this process to the next level of the queue, that is called the ready. So now from the ready queue, the CPU, there is another program that is called the short-term scheduler. So short-term scheduler find out the processes from the ready queue. It will select the process from the ready queue and hand over this process to the dispatcher. And from the dispatcher, it will go to the central processing unit, that is the CPU. So there are another scheduler is there, that is called the midterm scheduler. Assume that whenever the customer enters the dining hall, he or she may not like the table or the location of the table. So that's why she will again come back to the waiting queue or will stay in a different location. So this kind of request will be handled by the midterm scheduler. So who is the midterm scheduler? So whenever you enter to the restaurant, there is a person who will receive you. So he is the long-term scheduler. His processing or working style is quite slow. Next, the lady who will come from the dining hall. She is quite fast and smart enough to handle all the customer. She is the short-term scheduler. There is a person also standing in between kitchen and the dining hall. They are the dispatcher, and who is taking care all the tantrum of the customer. He or she is the midterm scheduler. Another. So these are the person are already working in the restaurant. Okay. Similarly, so this person with break time is the long-term scheduler. The lady here is standing. She is the short-term scheduler. This is the dispatcher program. This is the midterm program. Midterm scheduler or the midterm scheduler. So these are the things are occurring into our operating system. So this is the long-term scheduler. So what is long-term scheduler? What is this? So a long-term scheduler is also called the job scheduler. Long-term scheduler determines which program are admitted to the system. So you see, it selects processes from queue and loads them into the memory for execution. Process loads into the memory for scheduling. The primary objective of job scheduler is to provide a balanced mix of jobs, such as the IO bound and the processing. So in our operating system, there are two types of jobs. One job is the IO bound job, another one is the CPU bound job. So which kind of job it has to manage? It has to manage such a thing that is the balance between the IO bound and the CPU bound process. It also controls a degree of multi-programming. That means as much as possible number of processes will be handled by the CPU and your computer RAM. That means the degree of multi-programming will be increasing. So if the degree of multi-programming is stable, then the average rate of process creation must be equal to the average departure rate of processes leaving the system. On some system, the long-term scheduler may not be available or minimum. So some operating system long-term scheduler is absent also. In time-sharing operating system, have to long-term scheduler. When a process changes the states from new to ready, there is the use of long-term scheduler. So from the process new to ready, who is working? The long-term scheduler. Now, what are the function of short-term scheduler? Short-term scheduler is called the CPU scheduler. Its main objective is to increase system performance in accordance with the chosen set of criteria. It is the change of ready state to running process. So from ready queue to CPU, this short-term scheduler is working. CPU scheduler selects a process among the processes that are ready to execute and allocates CPU to one of them. Short-term scheduler, also known as dispatcher, makes the decision of which process to execute next. So short-term scheduler is not only working alone, she is also working with the dispatcher group. Okay, so short-term scheduler are faster than the long-term scheduler. So these are the point you have to remember. Next one is the midterm scheduler. So this person is the midterm scheduler. Just remember that. So midterm scheduling is part of swapping. It removes the process from the memory. It reduces the degree of multi-programming. The midterm scheduler is in charge of handling swapped out processes. A running process may become suspended if it makes IO request. A suspended process cannot make any process towards completion. In this condition, to remove the process from memory and make space for other process, the suspended process is moved to the secondary storage. This process is called swapping, and the process is said to swap out or roll out. Swapping may be necessary to improve the process mix. So what are the tasks of this person? It mainly handles the suspended process and free up your memory. It will decrease the degree of multi-programming. Assume there are lots of people are already accumulated in dining hall, but you don't have the food or you don't have the table to allocate to your customer. So that is why then this type of people are working who are managing or swap out the extra load from the CPU. Okay. So this is the dispatcher. Dispatcher is also another smart person. So dispatcher is responsible for loading processes selected by short-term scheduler on the CPU ready to running state. Context switching is done by dispatcher only. Dispatcher does following: switching context, switching the user mode, jumping to the proper location in the new loaded program. Okay, so this one is the dispatcher. Dispatcher is mainly handling the sequence of which customer will be served, which customer will be bill out, which customer will be has to serve the food, etc. That means the dispatcher is mainly responsible for the managing the dining, the main responsibility of the dispatcher itself. Okay, and this person is also working in very first. Okay, so these are the very basic difference between long-term scheduler and short-term scheduler and the mid-term scheduler. Now come to the first point. The long-term scheduler is called the job scheduler, short-term scheduler is called the CPU scheduler, and mid-term scheduler is mainly, it is a process swapping scheduler. In case of long-term scheduler, come to the second point, speed up is lesser than the short-term scheduler. Next is the short-term scheduler, speed is fastest. That means long-term scheduler are slow, short-term scheduler are fast, mid-term scheduler speed is between long-term scheduler and the short-term scheduler. They are mid-term scheduler speed is in between long-term scheduler and the short-term scheduler. This thing you have to remember. Number 3, it controls a degree of multi-programming. Short-term scheduler is also lesser control over the degree of multi-programming. Mid-term scheduler is also reduces the degree of multi-programming, as I have already told you. Number 4, it is also absent or minimal in the time sharing system. It is also minimal in the sharing system. It is part of time sharing system. So long-term scheduler is absent from the time sharing system. In short-term scheduler, its performance is minimal. In mid-term scheduler, it is a part of time sharing system. So number 5, it select process from pool and loads them into memory. Short-term scheduler select process which are ready to execute, and mid-term scheduler, it can reintroduce the process into memory and execution can be continued. Okay. So now I will come to the next point, that is the CPU scheduling criteria. So assume our computer is nothing but a machine, and we need to calculate the performance of the computer or the computer system or the central processing unit of your computer. So what are the main things you have to keep in mind? There are 2 things you have to keep in mind. That is, either you have to utilize something maximum way, or either you have to utilize something minimized way. So for the maximization, that means we can maximize the CPU and maximize the throughput. These are the 2 points we have to remember. And in case of minimization, that is the turnaround time, waiting time, and the response time. These are the 5 CPU scheduling criteria we have learned throughout this chapter. So first CPU scheduling criteria is the CPU utilization. Next one is the throughput. Third is the turnaround time. Fourth is the waiting time, and the 5th is the response time. In our CPU scheduling, among these 5 CPU scheduling criteria, CPU scheduling utilization and the throughput, these we have to design our algorithm in such a way CPU utilization will be maximum, throughput will be maximum, and we have to design our CPU scheduling algorithm in such a way we can minimize the turnaround time, we can minimize the waiting time, and we can minimize the response times. These are the 5 things we have to do. So these are the definition. What do you mean by CPU utilization? CPU utilization would be a CPU would be busy 100%. So as to 0 CPU cycle on a real system, CPU usable should range from 40% to 90%. Okay. Throughput means the number of processes completed per unit time. So how many processes are actually working per unit time. Turnaround time is the time required for a particular process to complete from the submission time of the time to completion. So waiting time is how much time process spent in the ready queue, waiting their turn to get into the CPU. And response time, the time taken in an interactive program from the issuance of comment to the comments of response to the comment. So just consider this example. There are 4 processes: process 0, process 1, process 2 and process 3. So waiting time, how we will calculate? The waiting time will be calculated by the starting time minus the arrival time. Remember one thing. So assuming there are arrival time 0, 1, 2, 3, and in the third column just see execution time. Process 0 execution time is 5, process 1 execution time is 3, process 2 execution time is 8, and process 3 execution time is 6. Now I am requesting you to ignore the fourth column, that is the service time. Now come to the next diagram. Here process 0 will be started at the time of arrival, that is 0. So process 0 execution time is 5. So after 5 seconds, process 0 completed execution and exit from the system. Next, who will come? Next, P1 will come. How much time P1 will execute? 3. So P1 will enter into the system at the time of 5. P1 will exit from the system at the time of 8. Similarly, for process 2 will enter now. Process 2 execution time is 8. So process 2 will enter into the system at the time of 8. After 8 seconds, that is the 16, it will exit from the system. Similarly, for process 3, it has arrived at 3, but its execution time is 6. So after 6 means at the time of 22, process 3 will complete its execution. So how we will calculate the waiting time? Waiting time will be calculated by for process 0. That is the formula is starting time of process 0 minus starting time of the process 0 minus arrival time of process 0. So starting time of process 0 is 0 and arrival time of process 0 is also 0. So 0 minus 0, that is 0. Waiting time for process 1. Process 1 arrived at the time, started their execution at the time of 5, but process 1 arrived into the system 1. So that is 5 minus 1 equal to 4 will be calculated. Similarly, waiting time for process 2. Process 2 has entered into the system at the time of 8, but process 2 arrived into our system at the time of 2. So 8 minus 2 equal to 6. Similarly, for process 3 has entered into the system 16, but it has arrived into the system 3. So waiting time for process 3 is 30. So by this manner, one by one, we can calculate the waiting time. Similarly, turnaround time. Turnaround time is, from this diagram, process 0 complete its execution at the time of 5. So similarly, completion time is 5 minus arrival time, that is the 5. Similarly, for process 1, completion time is 8. So 8 minus arrival time, that is the 1, that is 7. Turnaround time for process 2. Process 2 turnaround time is, completion time of process 2 is 16. But process 2 has arrived at 2. So 16 minus 2, this is the 14. Similarly, turnaround time for process 3. Process 3, this is the completion time of process 3 is 22. But process 3 has arrived equal to 3. So 22 minus 3 will be now 9. Similarly, that is the response time. Response time is also the first response time minus the arrival time. First response time is when you are getting the first response from the system after it has been submitted to the system. That means the first response time minus the arrival. So similarly, just in case of waiting time, in that case, response time is also similar. So process 0 first act upon at the time of 0. Process 1 will act upon at the time of 5. process 2 act upon at the time of 8. Process 3 is act upon at the time of 16. So that means 0 minus 0 equal to 0, 5 minus 1 equal to 4, 8 minus 2 equal to 6, 16 minus 3 equal to 13. These are the response times of the system. Response time is nothing but the whenever your CPU will give you the first attention. This is the response time. So now the types of CPU scheduling algorithm. There are two types of CPU scheduling algorithm: preemptive CPU scheduling algorithm and non-preemptive CPU scheduling algorithm. In preemption means we are forcibly stop one process to execute something or doing something and let them allow to go to the another state and wait for their turn whenever CPU will get free. So non-preemption means we will give CPU attention to a particular process until the execution is complete for that process. Other process has to wait to get the attention of CPU, and in that case, this kind of execution are called the non-preemption. Non-preemption means the continuous execution. There will be no interruption. So these are the scenario. Just see over here. So now here. This is the CPU. CPU is executing. Now consider the case 1. Case 1 is the from running state to waiting state. So case 1, just check here. Case 1 is the process will move from execution to waiting. Case 2 where running state to ready. Case 2 is where a system is running to ready. This is the case 2. Case 3 is the process switches from waiting state to ready state. So number 3 is here. Just see here. Number 3 is just see here. Number 3. So waiting state to ready state. And the number 4 is the process will be terminated. So in that case, process 1 and process 4. Process 1 and process 4 means ready to CPU. Process 1, CPU to waiting. Again, it will go to the CPU or it will complete its execution and terminate. So here number 4 step is the end. Okay. So 1 and 4 situation is called the process is non-preemption, and rest of the 2 case whenever the execution has interrupted. That is the situation 2 and the situation 3. This 2 and situation 3 are called the preemption. Okay, or preemptive scheduling criteria. So under non-preemption scheduling criteria, once the CPU has been allocated to a process and the process keeps the CPU until it releases the CPU either by terminating or by switching to the waiting state. This scheduling method is used by Microsoft Windows 3.1 version and by the Apple Macintosh operating system. It is the only method that can be used on certain hardware platforms because it does not require the special hardware needed for preemptive scheduling. And in case of preemptive scheduling, in this type of scheduling, the tasks are usually assigned with priorities at the times it is necessary to run certain tasks that has a higher priority before another task, although it is running. Therefore, running task is interrupted for some time and resumed later the priority task has finished its execution. So these are the difference between preemptive and non-preemptive scheduling. So we'll just go to the number 1 point. Scheduler has ability to move process from running state to other state and let other process run when interrupt occur. This is called preemptive scheduling. Non-preemptive scheduling cannot take up a processor away from a process, also called non-preemptive scheduling. Come to the number 2 points. Preemptive scheduling is helpful in multi-programming environment by using time slots. Using time slots and process cannot enter into infinite loop or lock the whole system. When we need processor to do not halt in middle of something. Very important non-preemptive environment is preferable. Processes in kernel mode usually run in non-preemptive mode. The process gives up control voluntarily. So these are the CPU scheduling algorithm we will study throughout this syllabus. The first one is the first come first serve, that is called the FCFS. Next one is the shortest of first. Next one is the shortest remaining time first. This is also called SJF with preemption. Next is the priority scheduling. Priority scheduling is two types: preemptive priority scheduling and non-preemptive priority scheduling. Next one we will study round robin scheduling algorithm. After that we will study multi-level queue scheduling algorithm, multi-level feedback queue scheduling algorithm at the end. So what is the summary we have learned from this chapter? When a process switches from the running state to the waiting state, when a process switches from running state to the ready state, when a process switches from waiting state to the ready state, when a process terminates, the success of a CPU scheduler depends on the design of high quality scheduling algorithm. Higher quality CPU scheduling algorithms rely mainly on the criteria such as CPU utilization rate, throughput, turnaround time, and the waiting time. So these are the books I have already recommended to you, and these are the important questions. Prepare them for the examination. You have to cover the process scheduling queues, long-term scheduler versus short-term scheduler. What is dispatcher, preemptive versus non-preemptive scheduling? Explain different CPU scheduling criteria. What is turnaround time? What is throughput? What is midterm scheduler? Where does it decide? This kind of question you have to remember. Okay. Thank you. These are the link wherever you can reach to us. And that's all for the day. Thank you.